questions, everything else. So as we go on, you can ask questions, you can stop me, you can do anything you want, and ask whatever questions you have. So the general gist of the slideshow of the presentation is tips and tricks on fabrication, right? How to fabricate high quality parts, even if you don't have thousands of dollars of tools, right? So if you don't have a CNC milling machine, if you don't have a CNC router, if you don't even have like a regular XY milling machine, what can you actually do on these things to still produce high quality parts? So I coach 4467. I also mentor 3504. My wife is generally an FRC widow during, I don't know, the majority of the year. And then I have a now 5 going on 6-year-old daughter that will one day do whatever the heck she wants and change the world in some minor way, maybe a major way, who knows, we'll see, not to put too much pressure on her. And so I've been doing FRC since 2013 on that. My day job, I work at Carnegie Mellon. I run the machine shop there. So I help do robots for things like DARPA, Iris Lunar Rover, Moon Ranger. Those are 2 lunar rovers that are going to the moon, and I help out building all sorts of different stuff for different people. You generally design around what you know, and what you know you can get fabricated, or what you can fabricate. It depends on your timeline, right? So if you have a machine shop that is set up with 5-axis machines and you can effectively run those parts very, very quickly throughout, you have a great workflow there. You're going to design different parts than a team or somebody that just has maybe a CNC router or just has a Bridgeport. You're going to design a different part. You're going to create a different part. This is a universal truth on design. Okay. The second thing, though, goes to a lot of teams can use this as an excuse. They go, well, we don't have that super fancy machining stuff, and so therefore we can't actually build high quality robots, right? Our robots are just going to be junky and they're not going to perform well because we don't have those amazing tools. And that is a complete and total fallacy. It's the poor craftsman that blames the tools, right? It doesn't mean that your tools don't matter, right? You need to have high quality, good tools, but if you have enough skills, you can work around that fact, right? So I love having great tools, but at the same time, you don't need those to make good quality robots. You can make good quality robots with the resources that are out there. I also believe in this: design it so the kids can do the work. What this means is that, yeah, I have a whole bunch of CNC machines at work and I have 4-axis machines and everything else. However, if you historically look at Titan's robots, you will not see parts on those that require that amount or that type of machining, because the kids are supposed to be doing that building, right? It's a mentor-student relationship, and the kids really should be doing as much of that work as possible. Job as a mentor is just to help enable them to do it. If you have, when I was teaching at Korean Tech Center, I was more inclined to do more complex machining when I had students on the team that were in the machine shop class. So we had the equipment and then the students were doing that stuff. But again, not a excuse. You can still build great robots without that. Here's a problem, right? You need to make 4 of these pieces and they need to be identical. So it's 1 inch, or it's 3/4 by 3/4, 2 inches long, and then you have a 1032 hole tapped in the center that is bisecting a 0.24 hole that is reamed there. And then you have a couple other holes. So this is a nice little orthographic drawing, and this is this. And you don't have a milling machine. This is actually a problem that I ran into over COVID. I had to do some testing for work, and I didn't have a milling machine here at my house. I only had a drill press. So what did I do? I used a drill press fence. So just about everybody has access to a drill press. Drill presses are also not an expensive tool. You can use a cheap one, you can go get a great one, but a drill press without this one feature, this one feature of a fence will really improve your fabrication ability on that fence or on that tool. And so a fence is just nothing more than a table with a straight line. This is a very complex fence where it has some stops, it has some clamps, it has everything else, but you can see that a fence can be nothing more than just a piece of 3/4 inch plywood with some angle on it. And that's really as simple as it gets. We clamp this to a drill press, and now we have a reference edge that goes on here. And on this, I can then take this piece of stock that I bought at 3/4 by 3/4, and I can find the actual center of the block on the y-axis. So how I do that is I just simply take that and I set the fence and I make a little mark and I flip the block around 180 degrees here. So I just take and flip it right this. And as long as that mark is getting lined up, I know that it is the center in the y-axis. And I can tap, if it's not there, I can tap the fence on the backside forward and backwards to make sure that it actually is. So I just keep flipping that block until the point lines up with itself right on the center line. Okay, so then after I do that, I need to find the center of the block in the x-axis. And the same exact thing happens there where I make a mark and I then line that up. And I've previously scribed the center, so I know exactly what that center is. So super easy to do. And now I can drill that hole right through the center of that. So that was the clearance hole. I can then move this and I can rotate it around, scribe another line, and now I can get two holes there that are my mounting holes. Those are those holes that are from the edge, right? Rotate it around again and line it up with that same mark, and voila. And then I just simply cross drill that, because all of those holes when I initially designed this were all in the center line, so on the Y. And so all I had to do was just kind of keep moving this around. And then I had to ream it and do the last operation there. So that's how you can create this custom part and have all of those be identical with just simply using a piece of 3/4 inch plywood and some old angle that you have around. Very, very useful. So the Titans have a whole bunch of hand tools, right? These are the real things that we use all the time, right? A ton of cordless hand drills, a lot of M12 and a lot of M18 from Milwaukee. We have a cold saw. I personally love a cold saw. We have historically used a miter saw. I would encourage every team that possibly can to not use a miter saw. They're too high of an RPM, and while they cut aluminum, they can do that very, very dangerously and really have the potential to hurt somebody. We have a bandsaw, a relatively nice bandsaw. For Girls of Steel, we just recently bought a Milwaukee Portaband with a swag off-road base. That is a fantastic medium price bandsaw for cutting metal and sheet and everything else.
Is that the one with the exposed blade, the long exposed blade in the foot pedal, or is it the other one?
Yes, that's the longer exposed blade with the foot pedal. So
I'll throw in my 2 cents. I don't like the long exposed blade in a foot pedal. It's a safety feature, but I'm a little picky.
It's not scary at all. So it's you're keeping your hand away from it anyway, and you should be good. But you could add an additional guard to that if you wanted to, Theodore, and make it a little bit safer. But from an actual like a tool that has the ability to cut, it does a great job. And then we have a CNC router that we use extensively. We have a drill press. I would highly recommend, if you don't have a cold saw and you don't have a budget to get a cold saw, they're about $1,200, to go with like an Evolution metal cutting saw that'll cut aluminum. nicely, and it clamps it while you're cutting. So you're not having your hand anywhere around it. And then we have a couple 3D printers that we use. These are some essential tools that I think every team should get, right? You need to have buy a pile of clamps floating around your shop. These clamps can be anything from these Irwin quick grip clamps. We use them a ton. I really like them. These larger vice grip C clamps, you can get these from Harbor Freight for about $5 a piece or less, depending on whether you have a coupon or they're on sale. These longer needle nose vice grips are really good. And then you should have at least 1 to 2 vices in your shop that are permanently mounted to a table very, very securely. That's a huge thing to have, is vices, right? And work holding strategies. We bought this year a 3-jaw chuck. So most people are familiar with this. You're familiar with that in the context of you see it on a lathe. But you can buy these chucks. They're about 25 to 30 bucks on Amazon. About a 4 or a 6-inch version is what you want to be buying. And you can get this, and where this comes into play is holding round items. So most of the time with a hex shaft, you can hold it in a vise pretty effectively because it's got 2 parallel sides, so you can hold that. But when you get into round stock here, that becomes very, very difficult to hold effectively in a regular vise. So a 3-jaw chuck is a great way of doing this. I have these at work, and I haven't gotten to it for the Titans yet, but I have them mounted onto a plate on the base. So it's just a plate of aluminum that's a square rectangle that I can then clamp down onto a milling machine or a drill press. And where this comes into play is if you actually needed to drill a hole into the center of hex stock or something else that you wanted to drill the hole exactly in the center. You could use a regular drill bit here and have that chuck clamped onto the table, use something that already has a hole in the middle to find that dead center. And then once you open this up and change out the part, now all of a sudden you're drilling a hole in whatever circular object is pretty close to exactly the center of it. And you don't have to have a lathe. You can do that with just a straight drill press. So another reason why kind of that drill press is pretty essential. You can do it with a fence, but you can also do something like this and have a round piece of stock on it. Okay. Layout tools, having proper good measurement tools and layout tools are effective. So this in the top left is called a combination square. Most of the time you can get these really cheap on Amazon, where it's just the right angle side right here. You don't necessarily need the protractor or the centering head on this, and you don't need to buy the full machinist one. But these come in really effective because you can use them to find the center of something. You can use them as just a 90-degree angle or a 45. But more importantly, you can use them to do repeated measurements on everything. And a lot of times in FRC, it's more important for us to have something that is exactly in the same location every time on the left-hand side, on the right-hand side of the robot, or the front and the back, than it is for it to be exactly 2 inches away from something, okay? A set of dividers right here, super helpful. Speed square, a center punch, and a good center punch. This is an automatic spring-loaded one. I would highly recommend, if you're not going to spend the money on a good center punch, like a self-centering one from like SCRA, to go and just buy a center punch set that is just manual, that you have to use a hammer and hit with, because they'll last much longer. The cheaper spring-loaded centering punches just do not last. This is on the left-hand side, is called a layout fluid. I really recommend having layout fluid around your shop for a reason that we're going to talk about. But if you're buying layout fluid, do not buy red layout fluid. Buy blue layout fluid. You can see what red layout fluid looks like if you spill it. Okay, red layout fluid, when you spill it, looks like you just bled everywhere. Not that great. blue layout fluid, it looks blue, and you're not going to notice it as, as blood. Now, good measurement tools are critical. So I really like getting good dial calipers that have metal ends, and that's because I use these to scribe lines on different things so that they're exactly 1 inch, exactly 1 1/8 inches, things like that. And if you're getting different tape measures, make sure your tape measures that you have in your shop are actually accurate. A lot of teams, they'll go and they'll get something from Harbor Freight, and then Harbor Freight will throw in the free tape measure. And it's really common on those tape measures to see something that is different right here. If you look at the tape measure on the top and the tape measure on the bottom, the 1 inch and the 2 inch, they don't all line up. So that means if a student is using tape measure A and they tell the measurement to somebody else that is using tape measure B, then all of a sudden you're going to have parts that don't fit. So pretty important to make sure that those are good measurement tools. And I highly recommend having 6-inch dial calipers that are digital floating around your shop. Drill bits, right? Get a good set of drill bits, but don't just buy a set, okay? So we don't really use that many hole saws around Titans or really Goss anymore. We do have them, but we don't really use them a lot. We use a lot of step drills, which is this drill right in the middle here, or sorry, on the right-hand side. And then we use a lot of twist drills. The drill bits the other drills that you see, this is called a paddle or a flat bit, the one with 22 on it. This is good for drilling into wood and sometimes good for drilling into things like polycarbonate. The brad point is also good for wood or polycarbonate. The auger is really good if you're doing larger holes in wood. It has a screw tip on there. But essentially, when you're doing stuff for FRC, what you're really looking for is you want a large quantity of this drill bit and a large quantity of this drill bit right there. If you have those in your shop, you're going to be in great shape. And you want to watch when you're buying the step drill bit that you buy the step drill bit that has the maximum diameter of 1 1/8 inches. And that's because it's really easy to drill a bearing hole by just taking that 1 1/8 inches step drill bit and going all the way through something, then instead of trying to stop and see, oh, did I hit this? Okay. We also buy a lot of taps, right? We do 1/4 20. We also do 3/8 16, and we do 1032. We also have 440s and stuff like that floating around. But the type of tap that you select is going to be dependent on the type of material and how you're removing that. I'll share these slides out at the end of this, but on the bottom of this is a great link to a video that talks about the different types of taps. So you can see on this, these are both a spiral fluted tap, but one is what's called a bottoming tap. The other is a taper tap. You can see how on the front side of this, it only has a few threads, and on up here, it's a shorter lead in. This is gonna bottom out, but it's gonna be a lot harder and not starting threads. When your starting threads are going into a blind hole or even something like Thunder Hex, you wanna use something closer to this where it has a lead in. There. Understanding the drills that you have, we use the torque setting on our drills when we are tapping things. And so for Titans, we don't hand tap stuff with a T-handled wrench. We chuck it up in a drill and we power tap it. And that's probably 99% of the time that we do power tapping. And when we're doing that, we make sure that we're on the torque setting. And the torque is just a clutch in there that makes sure that you don't snap the drill or snap the tap. You don't break a tap. When we're tapping, we also use a lot of lubricant. For us, that's WD-40. For other people, they might do Tap Magic. We use WD-40 because we find it's good for just about everything that we do on our team. And so we only have to do one cutting oil. Okay. This one is a really key one. Don't buy the wrong drill bits, right? It's very common that everybody goes out and they buy a drill index set and it has numbered and it has letters and it has this. But the problem is it only has one of each one of those drill bits. So you end up with a whole bunch of drills that you don't need and only one of the drill bit that you do need. Go out and purposely buy just the right drill bits for whatever you are doing for FRC, okay? This is it. You only need 7 to 8 drill bits. 36 is the tap drill for 632. Number 27 is the close fit for number 6 hardware, and the tap drill for 832 with a 50% thread engagement. It's not necessarily okay to have 50% engagement for aluminum, but it's good for steel. You could get by with it in aluminum. Number 29 is a tap drill bit for 832 with 75%. So if you're running cheap, get the 27s. If you have a little bit of extra cash, spend the extra $12 and get the 29s, right? And get a pack of them, right? 18 is close fit for number 8 hardware. That means that if you drilled that, the number 8 will fit right through it. Number 21 is the tap drill for 1032 and a rivet hole for 5/32 rivets. Number 7 is a tap drill for 1/420. By the way, if you use number 21, you can use that also for a very free fit for number 8 hardware. So there you go. And an F drill bit is close fit for number 10 hardware and is a tap drill for 5/16 18. We started using a lot of 5/16 18 this year for doing shoulder bolts on rotating fasteners. So we started doing shoulder bolts. That's a 3/8 inch shoulder bolt with a 3/8 inch bearing that captures it. I like this drill chart by Little Machine Shop, but FRC Vex has a very nice concise poster right here, and there you go. I buy drill bits from MSC, and when I do, I generally buy screw machine length drill bits for those that are 135-degree tip with a split point. You can go buy other cheaper ones, but I kind of like having nice drill bits that hold up for the students. They don't have to resharpen them every time. We also have a drill bit sharpener on the Titans that it takes a little bit of time to get the students to use it, but it means that we're not throwing drill bits in the garbage. We're just resharpening them. And when students resharpen them, they have to test those and actually inspect that they actually work, because it's very common for students to sharpen a drill bit and it turns out that they didn't really sharpen a drill bit. It doesn't work at all. I like this chart. Vex sends this out every single year with a kit of parts, so you probably have 5 or 6 of them floating around. It's nice because this chart shows out what the free, the close, what the bolt diameter, and the tap size is, and it kind of gives you this concept of why we use 6, 8, 10, and quarters in the land of FRC, because of how closely those drill bit sizes all work. It also gives us the head size of certain bolts. Okay. There are certain bolts in FRC that have to be metric. If you are putting on the 775 Pros or you're using those have a metric bolt on those that you need to use. Because metric bolts in the land of FRC are so they're a necessary evil, where we're only using them in 1 or 2 locations. And the size of those bolts is really close to the standard sizes of bolts that we have, where a student could take an M3 bolt and they could start threading it into a hole that's an 832. And if that student isn't paying attention, they could actually strip that out. The threads will just engage enough that the student will think that it's somewhat tight and they'll keep working at it and it'll strip out. I highly recommend, when you buy the metric, buy the color-coded stuff. You can go to McMaster Carr and you can buy blue bolts that are alloy steel bolts, and they're just blue, and you can get them in any size. Go buy those. You can also buy blue wrenches that are also metric. So this means the students have a really easy system that if it's blue, they use it and they know it's metric. That's it, right? We also do a lot on the Titans with strip heaters. So we bend a fair amount of polycarbonate. Strip heaters are really relatively expensive. This red one here, it's about $224. But it makes bending polycarbonate unbelievably easy to do and really get a clean result. You can do the same thing with a heat gun. Heat guns are not hair dryers. They're way more powerful than that. And you can get directional heat on that. If you're doing this type of work, don't forget gloves. But it's really easy to bend polycarbonate to get all sorts of different shapes It's easy also to mock those bent shapes up with cardboard. We do that a fair amount where we'll make a pattern out of cardboard, and then we'll go and we'll bend it with polycarbonate because it's a little bit more expensive. If you're using a jigsaw, right? If you don't have a great bandsaw, the jigsaw is awesome for just about everything in FRC. A jigsaw cuts through it really, really well. Aluminum, if you have the right blade, it cuts it. Polycarbonate, wood, cuts through aluminum sheet. It cuts through all of those things. But you need to make sure that you have the right blade, and you also need to make sure that you are having a variable speed one really also does help. And play around with that, right? When we talk about machine tools, we have a speed, which is the speed that the blade is actually moving. And then we also have a feed, which is the blade, the rate at which you're moving the tool through the workpiece. Okay, this is the type of blades that are generally common. If you look at this, the coarse teeth down here are really great for wood, but they're not that great for other stuff. Don't use them for aluminum, don't use them for plastic. They're just too coarse. I really like this progressive all-purpose for cutting polycarbonate or a clean wood blade. Both of those do a really good job. And then I use the progressive metal or the basic metal for cutting aluminum. And believe it or not, if you're using your tool and you're using a jigsaw and you're not doing it for like fine precision woodworking, the occasional squirt of WD-40 is really going to help make a blade last if you're cutting through aluminum, right? It's going to keep that from going. And you also want to make sure that you slow your speed, the rate at which the tool is reciprocating, down, because the aluminum will melt to the blade and also the plastic will melt to the blade if you're going too fast. So I'm not even sure if the students on the Titans know that our our jigsaw is actually clocked down on the speed that it goes. It's a variable speed, and there's a thumb on the back, and I've just set it down lower so that even when the student pulls the trigger the whole way, it's not melting through. I also really like if you have a can't confirm I did not know that. If you have what's called a sawzall, those are also super useful. Students on Titans probably last Monday would have loved to have a sawzall around. Instead, they used a hacksaw, and they used a good quality hacksaw. So I have a track saw. It's been multiple years since we have used the track saw on the Titans. But a track saw is just simply a tool that cuts a straight line. And what's nice about a track saw is you can set definitive depths. So in 2016, we used just simply a track saw to do a whole bunch of cutting on aluminum sheet to give us a funnel for our gears. And we actually then curve cut and bent all of that stuff around. Made it really nice and useful. But a track saw was useful for that. I wouldn't call it a critical tool for an FRC team. They're also relatively expensive. They were about $500. You can make a cheap one out of just wood and a circular saw and kind of get the effective same thing. So what type of aluminum do you buy? This is going to depend on what you want to do. There's aluminum is not just aluminum, right? There is multiple different types. 3003 aluminum is a bendable aluminum, but not weldable. So if you take a sheet of this and you go to bend it, it will bend for you. But if you tried to weld it up, it's not going to weld. 5052 is a bendable alloy, but it is weldable. That's really good for you. 6061 is not bendable, but it is weldable. Most of your aluminum tubing that you get from like Vex or other vendors is going to be 6061. And your angle and your sheet, all that stuff is generally 6061 from different vendors. You can bend this, and we've all seen that it will bend. But when I'm talking about not bendable, I mean that it won't bend to about a 90-degree angle without stress fracturing right there. You can get probably about a 20 or 30 degree without it stress fracturing, but anything over that, it stress fractures. And what'll happen is it'll look like it's bent and it'll look like it's solid, but the second that you go to put a load on it, it'll just snap, which is really unfortunate because that generally is right when you're on the field. 6063 is this grade of aluminum that is an architectural grade. If you go to like Lowe's or Home Depot or something like that and you get aluminum tubing, a lot of times that'll actually be 6063. 6063 is not as strong as 6061 by an order of magnitude. There's a really great website called Make It From. Again, when I share these out, you can go onto that website and you can look at the different aluminum alloys and you can look at what their tensile strength is, what their modulus of elasticity is, all of these different factors that factor into the strength of a material. And when you look at 6063 and you look at 6061, you'll see that they are very, very different. It's not just two letters, but it's a very large factor. 7075.
I would say be careful with first choice when you're getting stuff from there, because some of the 1x1 and other stuff actually is 6063,
Correct.
which is yeah.
Yep. It's really common, and why it's that way is because it is difficult to get 6061 in the thin walls that are there, right? And when you get down in the 6063, they will offer that in different sizes, different wall thicknesses that are all really, really thin. And so that's kind of why that happens. So you do have to watch out. And that goes for anything, any website. If you go to like Online Metals and you're like, I want 2x1 and I want 0.0625, it'll show you, hey, we have that, but it'll be 6063. And that's kind of unfortunate sometimes. 7075 is a aluminum plate. It is not bendable. It is very, very tough. And it is also not weldable, but it's a phenomenal alloy. We use it from time to time for gearbox plates, but that's about where Titan stop and also where Goss stops on using it. But we'll use it a fair amount. Even at work, we'll use it for different things. We're just selective. So it's kind of like understanding what different type of, it is. If you go down the bread aisle, there's not just one style of bread. Just like with aluminum, it's not just one style of aluminum. So make sure you understand what those are and try to get an understanding of where you would use those. It's really going to help you, right, as you do it. Fasteners, right? 2 points constrain a line, 3 points constrain a plane. Adding excess fasteners simply increases the likelihood of holes not necessarily lining up. Additionally, don't underestimate the strength of fasteners. A single number 6 can easily support 100 pounds. So back in the day when, 10 years ago, I didn't quite totally understand this. I was so used to building and overbuilding things that everything to me was like a 1/4 inch, 1/4 fastener. And I didn't really value number 4s, number 6s, number 8s, number 10s. And so I really would encourage you to use, to think, do you need that many fasteners, right? Just because a plate that you get from Vex or AndyMark has holes for 12 rivets in it does not necessarily mean that you need to put all 12 rivets in there. Okay. So that's something that is there. And then the other side of this is when you're going to drill these things, I encourage people to do what's called match drilling. That means that when you go to do that rivet plate, you drill one hole, you put a rivet in, and then from there, you drill another hole and you put another rivet in. You're match drilling these things so that they actually have a high likelihood of lining up. The more points of constraint you have, the harder something is to go together. Riveting tools, right? I don't know how many of you use pop rivets on your team. Titans use them a fair amount. We've actually used them less and less. There were almost none on the 2022 robot, but historically we've used them a lot. hand riveters are awesome. Have one of them around. We have them in our field kit, but the Milwaukee M12 rivet gun is the cat's meow. It really helps out and saves students from killing their hands. So highly recommend getting one of those. With rivets, it's really important that you understand the thickness of material that you're using and that you select the right type of rivet. Rivets also come in different materials. So there's multiple different parts of those. A mandrel right here is generally made out of steel or aluminum. It gets pulled up, and when it pulls up, it flares out the body of the rivet right here. It flares that up, and then it breaks off from just tension. And so that right there is compressing the whole entire two pieces together. It's also forming a shear plane if you tried to shear those out. All the rivets, when you go to McMaster Carr, will list out what they are in a tensile strength that's pulling two items apart, as well as a shear. So it's nice to look at an all aluminum rivet, an all steel rivet, things like that, and really think about what they're capable of doing and what that force is there. We use 5/32 rivets, and the reason is because we can do 21 drill bit. We can do that tap drill for a 1032 right there and run those, and then we can also just drill them out. So it's super nice for us. This is a mistype. As we do this, another thing to realize is there is this thing called a countersunk rivet or a flathead rivet. These are super useful if you need to have two items riveted together, but you need to have a flat surface on the top. The domed rivet will not allow for two things to go apart. On Titan's 2022 robot, we use this to hold our whole entire shooter together in a lot of different places. Where we countersunk that, we took an 82-degree countersunk bit. We countersunk after we did the hole. So something to be aware of. And that's just slightly different, but really, really useful for you. You can also do PEMserts and what's called riv nuts. So on a piece of sheet metal, it's really hard to get threads to hold into that sheet metal if it's really thin, especially using aluminum. And so this item, which is called a PEMsert, will allow you to do holes, threaded holes in sheet metal. If you look at a lot of commercially or produced items, that's something that they use a lot of, is these PEMserts. You use that with a special tool. The other tool is called a riv nut. This also allows you to put threads into sheet metal. Girls of Steel uses this a fair amount this year, where they did PEMserts to allow for items to hold in and really have a good thread. It allows you to have a large quantity of threads without having to deal with a nut. You do need a special tool to put them in, but that tool is super useful for you. And there's a little bit of a procedure. If you show up to the Sunday meeting, we'll kind of go over that procedure to put those in. Threads on plastic. With the prevalence of 3D printing, this has become super, super important for us. And so with those, we use what's called heat certs or a heat set. You can either press those in or you can melt them in. I always prefer to melt them in. I have an old kind of wood burner soldering iron that has different tips onto that. And then I use that to simply melt those in. You go on the McMaster Carr, you look up the size, and then you model that right into whatever 3D printed part you're doing. And now you have a 3D printed part that can have a mechanical fastener on there that is really reliable for you. Heat certs are used in all sorts of commercial non-3D printed parts as well. So if you look at just about anything that's plastic that you're taking in and apart, it'll have a little tiny metal piece that is inserted in, and that's how they're doing it. So highly recommend using them for 3D printed parts as well. We use a thread checker on the Titans. We have 2 or 3 of these around the shop. It lets us identify bolts very, very easily. They're about $50 on Amazon. You get them in a long string. It has US bolts. It has English and metric. It has a lot of the sizes that you don't necessarily need. If you wanted to build just your own for FRC, you could buy the following standoffs from McMaster Carr. And you could then cross drill those and then add some wire and use them for mounting. And that would cost you about $25 from McMaster Carr if you bought those items. So the next time Titans probably needs one, that's probably what we'll do, is I'll just buy a pack of those items and do it that way. Or even probably Goss. It's just a matter of having students that have the time to cross drill all of those and run a wire through it. Loctite is your friend unless you're polycarbonate. Okay, so if you are polycarbonate plastic and you get Loctite on you, you will then actually break down and you'll have stress fractures all throughout, which will then cause that polycarbonate to break, very similar to acrylic. If you know the difference between acrylic and polycarbonate, you want to use polycarbonate on robots, not acrylic. And if you get Loctite anywhere near polycarbonate, it will turn it into that. There's a really great chart that goes over the different types. For general, Loctite 242 is a pretty good version for all of the stuff that you're doing in FRC. You can go down to what is called a pink or a purple Loctite. It kind of looks a pinkish color, and that's a low strength that works really great for 832s, 632s, and lower. So that's something to be aware of. If you have Loctite on something and there's too much Loctite, this really happened a lot with Falcons, right? Where Falcons, if you were dealing with them, certain bolts on Falcons had too much Loctite, and then other bolts had not enough or none at all. And so you had to kind of rebuild your Falcons this year and in 2020. And Loctite will actually break down with temperature. So if you have a bolt that you've Loctited together and it's too tight, it won't come apart. Just simply take a heat gun to that and heat it up to about 200-300 degrees, and it'll actually break down. In the chart here, it actually gives you all the breakdown temperatures, but really it's just take a heat gun to it for about 30-40 seconds, and generally that'll break the Loctite for you. And that even works with everything. They do sell like a high strength, high temp Loctite that is the cruelest thing that you could ever do to somebody. So you should never be having that for FRC, but you know, if you get into mechanical engineering and you want to play a cruel joke on all the technicians and make every technician that you ever work with hate you, you can just use that.
Can I just say, please don't put the retaining compound on the shafts, like inside of bearings. Like, try to keep it to the
so they do make a they do make
bearing.
retaining compound. Retaining compound is useful in certain areas. They also do make a Loctite that is for polycarbonate. It's closer to a cyanoacrylic glue. It's closer to a super glue than the anaerobic adhesive. So if you're going to use Loctite on polycarbonate, make sure you're buying the right one there. Titans and Goss color code everything. Okay, so we color code all of this stuff here. So you can see our 440 drill bits and taps are purple. Our 632 taps and drills are blue. The wrenches that fit those are generally the same exact color for a socket head. So we have these floating around our shop. This is available to anybody else when you get the thing, but you can also see that our bins in the drawer are also color coded that. So it's really easy for you to open up the drawer, grab the wrench that you need. The students in our pit, we just know yellow, give me a yellow, give me a green. I need a yellow and 2 greens, right? I need an open end in this. And that's how we kind of communicate during pit stops and everything else to get stuff done really quick. We also, huge believer in mobile storage systems. So this is a very easy bin to build for these Harbor Freight bins. This is how we store a whole bunch of parts. And then these are DeWalt T-stacks. They're an affordable option for you with drawers. We have these set up as field kits that we can take and go with us to practice fields, go with us to outreach events, and they store critical tools for us. So when we go to a different event, we can take one of these bins, it has all the critical first aid kits that we have for a mechanism, and we can take this, and we know that we will have all the tools that we need to fix something when we're at a practice field or when we go to an event. But the other nice thing is when we're at competitions, we can actually wheel these stacks over to another team's pit when we're helping them out. And then we're not fighting over where to find tools in somebody else's pit. We're just grabbing the tools that we know we need and using it that way. These are super critical for us and really invaluable, this mobile storage system. The other thing is we do have stationary storage systems in the shop. This is actually photos of the way that we have it arranged for GOS. We have these huge bin shelves. I've come up with a new one, which is just using bakery racks to store these, which is a little bit lighter duty on organizing. And those have actually become super prevalent. You can actually, interestingly enough, see one in the back right here. Goss calls that one Bread Boy. Teodora helped build that a long time ago. Prototypes, when you build prototypes, we'll talk about this later on in the summer, but prototypes, simple and modular, right? And so, and then we do modular construction techniques on Titans a lot. You can see the riveted and gusseted style, and then there's a room for adjustability on this. So this was a linkage in 2014. You can see multiple different bolt hole mounting locations, and that was due to the fact that we weren't exactly sure what that linkage system was supposed to look like or how it was going to function. So we designed that where we could just move the bolt and have a totally different shot if we needed to. We also had adjustability with sliding bearing blocks, things like that on that system. Also designed for safety. Long time ago, we had this as a robot cart. It was a hydraulic cart right here with a hole cut out so you could get to things on the bottom, a big thing. It turned out that it was just too big for us to manage at different competitions, off seasons and everything else. But you can see one of the things that we did was we had a safety set up there that allowed us to make sure that when we were working underneath this, that nobody would ever hit the valve and lower this by accident on somebody's hand. Okay, make sure that you have orders of operation for your robot, and make sure that you have policies, steps, pins in, so that you are not hurting any students. So any questions on any of this stuff? There's some of the hands-on stuff that we'll go over in person on Sunday if you attend that event, but then that's generally what we have there. Any questions?
I just want to say thank you. This was great.
Yep, no problem. Yeah, and there's a whole bunch of other stuff. I mean, building things is kind of critical. We'll go over layout in a little bit more detail on Sunday. So cool.